play a different version of Race to 120, specifically working on students making new groups of 10 and working on their proof drawings here. So if I were to roll the dice the first time, I would get the number, there we go, 11. So I'm going to start with 11, and I'm going to build 11. Now I'm going to take 11 and I'm going to roll the dice and I'm going to add a new number. So I get 5. So I'm going to add 5 more ones. And I can say that equation even. And as I know that 1 plus 5 equals 6, and I'm going to write my equation here, 11 plus 5 equals, and now I'm going to build that number at the bottom of my sheet here if you want that extra step, or you can just have first graders add it up in their heads. But I like the idea of having to document the 10s, document the 1s, and then write what it is. My number is 16. So I know that 11 plus 5 is 16. To know that I'm right, I'm going to start with what I had, 11. I'm going to add 5 more, 1, 2, 3, 4, 5, and I can tell that I have 16. I don't have enough ones to make a new group. So now that I have 16, I'm going to start with the number 16, and I'm going to add again. And now this time I have 9. So I'm going to add 9 extra ones, which I can tell I need 4 extra to make a 10, but I'm going to add 9 more. I now can see that I made a group of 10. So now that I made up a new group of 10, I'm going to trade it in for a group of 10, and I have 5 extra ones. So I had 16 and I needed to add 9 more. So 16 plus 9 should be, I'm going to erase the bottom of my mat, and now I have 10, 20 plus 5, I have 25. Let's see if we're right up here. So now I have 16 plus 9. I can make a new group of 10. And now I have 10, 20, 21, 22, 23, 24, 25. 16 plus 9 equals 25. Now I'm going to continue to play the game until the first person gets to 120. Now, as students are ready to add more than just a single digit number, you can either add in a third die, so that now students have to add up all 3 die to get a larger number to add here, or you can trade in and put in a 10 die. So you should have blank white cubes that come in most manipulative kits. You can write 10s on all the sides. You can use a wooden cube like I have here, and I put 10 on all the sides. And so then that way it's always going to be 10 and then whatever number. So in this case, I would have to add 19. So let's say that I had to add 19 next. And so I had 25 and I needed to add 19. In order to add 19, I know that 19 is one group of 10 and 9 extra ones. I have enough to make a new group of 10. So let's add up what we have. I have 10, 20, 30, 40, plus, should be 4 there, equals 44. Let's come back up here and see if I'm right. If I had 25 plus 19, can I make a new 10? I can. I made a new group of 10. Let's count our 10s. In fact, I'm going to trace them this time so I can keep track. 10, 20, 30, 40. How many ones do I have? 41, 42, 43, 44. My new number is 44. They match. I can keep going. Now, you can also take a cube and put all the decade numbers on it, like 10, 20, 30, 40, so that you're adding a larger 2-digit number every time. So you would roll this die, and then you roll these 2 die to get that ones place. That's going to make the game go much faster, but you're also adding larger numbers, where every time you have your existing number and you're having to add new 10 sticks, and you're going to regroup more often. If students continue to struggle, or the proof picture is difficult for them and they're not yet there, they may have to keep track on a 120 chart. They fill in their first number. The next time they add with a different color. The next time they add with a different color. And this would be another way to check to see that their answer is correct. Right now, we're using a proof drawing to make sure our answer is correct, but this could be even a third or a secondary tool to ensure that students are continuing to add each number correctly.